Hello everyone, I am Aishwarya, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to see a topic t-test in the course Statistical Foundation of Data Analysis. First we are going to see what is a t-test. A t-test, which is also known as student's t-test, is a tool for evaluating the means of one or two populations using hypothesis testing. Also, it may be used to evaluate whether a single group differs from a known value or whether two groups differ from each other or whether there is a significant difference in paired measurement. Next, we are going to see how this t-test is used. First, we define the hypothesis. We are going to test and specify an acceptable risk of drawing a faulty conclusion. For example, when comparing two populations, we might hypothesize that their means are the same, and we decide on an acceptable probability of concluding that a difference exists when that is not true. Next, we calculate the test statistics from your data and compare it to a theoretical value from a t-distribution. Depending on the outcome, we either reject or fail to reject our null hypothesis. Next, we are going to see the t-test assumptions. While t-tests are relatively robust to deviations from assumption, t-tests do assume that the data are continuous. The sample data have been randomly sampled from a population. There is homogeneity of variance, that is, the variability of a data in each group is similar. The distribution is approximately normal. For two-sample t-test, we must have independent samples. If the samples are not independent, then a paired t-test may be appropriate. Next, we are going to see an example of when a t-test would be used. Imagine that the drug manufacturer tests a new medicine. Following standard procedure, the drug is given to one group of patients and a placebo is given to another group called the control group. The placebo is a substance with no therapeutic value and serves as a benchmark to measure how the other group administered the actual drug response. After the drug trial, the members of the control group reported an increase in average life expectancy of 3 years. Members of the group that was prescribed the new drug reported an increase in average life expectancy of 4 years. Initial observation indicates that the drug is working. However, it is possible that the observation may be due to chance. A t-test can be used to determine if the results are significant and applicable to entire population or whether they are random and not due to the drug intervention. Next, we are going to see a formula in t-test. So, the first one is t-test statistic formula for the test of significant difference between sample mean and the population mean. So, the formula is t is equal to x bar minus mu divided by s by root n. Here, x bar denotes the sample mean, mu denotes the population mean, and s denotes the sample standard deviation, and n is the sample size. So the next formula is t-test statistic formula for the test of significant difference to samples. So the formula is t is equal to x1 bar minus x2 bar divided by root of s1 squared by n1 plus s2 squared by n2. Here x1 bar and x2 are sample means and s1 square and s2 square are the sample variance and n1 2 and n2 are the two sample sizes. So the next one is the procedure for finding the significant difference between sample mean and population mean for t-test for small sample. First we are going to define the hypothesis. So the first one is the null hypothesis, that is H0. So here the null hypothesis is sample mean which is equal to population mean, and the alternative hypothesis H alpha is equal to sample mean which is not equal to population mean. And the next step is we have to calculate the t statistic. The formula for the t statistic is t is equal to x bar minus mu divided by s by root n. So next we have to find the degrees of freedom. So here the formula for the degrees of freedom is df is equal to n minus 1. After that, we have to compare the critical value. Use a t table to find the critical value based on the significance level. So next we have to make a decision. If the modulus of t is greater than the critical value, we have to reject the null hypothesis. If the modulus t is less than the critical value, we have to accept the alternative hypothesis. So finally we conclude that if rejected, the sample mean is significantly different from the population mean. If the null hypothesis is not rejected, no strong evidence of a difference. So the next one is application of the student's t distribution. So the first one is used for testing the population mean. That is, it is used to check if a sample mean is significantly different from a population mean, especially when the sample size is small and the population standard deviation is unknown. And the next, it is used in comparing two sample means. It helps determine if two groups have significantly different means. And the third one is it used to calculate paired t-test. That is, it is used when the same group is tested twice. And the last one is confidence intervals for small samples. That is, it is used to estimate the range within which the population mean lies based on a small sample. So in this video, we are seeing what are the t-tests and what are the application of t-tests and what are the formulas and the procedure for calculating the t-formula. In the next video, we are going to see a problem based on the t-test. Thank you.